Hello folks, and welcome to the channel, or welcome back. And in this video we're going to try to answer the question if it does make sense to bypass or blank out the EGR valve on a Landrover Defender. And there is a lot of chit chat on the internet about the EGR valve. I grew up as a farmer's boy, and if there's something that we can say about farmers is that they have a lot of common sense. And we're going to apply some common sense here. And therefore we're going to answer three main questions. And once we have the answers to those questions, then we can all make up our own mind what we think about blanking out the EGR valve or not. I will blank out mine because I have my reasons, and I will explain them why I'm doing it. I will show you how to do it, but I also will show you on how you can test your EGR valve if you want to keep it. Because after all, the proof is in eating the pudding. And we have three questions for which we seek an answer. Why do we have an EGR valve? How does it work? And what happens if you remove it? Why do we have an EGR valve? Well, the answer to that is purely out of legislation for environmental control. That's all what it is. When Landrover developed the turbo diesels, they were using a turbo to force air into the cylinders. And the more air you can get into the cylinders, the more oxygen you get in. The more efficient the burning is, the more power you get, the more efficiency you get out of the engine. But the side effect is that you are burning at high temperatures. And if you have high temperatures, then the amount of NOx gases increases. And that's exactly what the legislation wanted to prevent. So Land Rover invented a system, and they are not the only one, by the way, which is called EGR, which is emission gas recirculation. So we're going to feed back exhaust gases back into the intake manifold to reduce the amount of oxygen in the air mixture, which is going into the cylinder. And that way, the burning temperatures are going down and the NOx gases are reduced. The only drawback is you're losing efficiency and you're losing power. So you're kind of defeating the whole purpose of having a turbo. And that is why Land Rover has implemented what we call a modulated EGR valve. It's only going to work when you don't need the power. If you're going to need power on the engine and performance, then it's not going to feed back those gases. So I have a drawing on the board, and we can have a look on it on how well that works, which is the answer to the second question. But before we do so, I'm going to show you the parts on the Landrover Defender. So the first thing I'm going to take away is actually the sound insulation cover on the engine. I already undid the bolts, and now we can have a closer look on where all these parts are. And it's also a good idea to take the shroud away on top of the radiator. That will give us a better view. We have our air intake through the air filter, then coming out, going to the MAF, which is our mass airflow sensor. And then it's going actually all the way around to the turbo. And this is the activator for the wastegate on the turbo. The turbo is right here. So the turbo will now compress the air and then sense it all the way back to the front of the engine where we find the intercooler. The compressed air from the turbo then enters the intercooler, flows through the intercooler and gets back out on the other side. The cooled air coming from the intercooler is then hitting the EGR valve, and this is the EGR valve. You can see on the top a vacuum hose. That's going to activate a membrane inside to open or close the actual EGR valve itself, which is actually coming from the exhaust, and I'll show you that hose in a few seconds. This one is a Euro 3, so there's a little side butterfly as well. So I have two controls. We've got the EGR valve itself that controls the EGR valve, and on the side we have a butterfly inside the EGR housing, which can block off air incoming from the intercooler. And then the output of the EGR valve goes back into the intake manifold and feeds the cylinders. And that's the pipe which is actually connected to the exhaust manifold, which is feeding back the exhaust fumes through a cooling system for the exhaust fumes, but this is only on the Euro 3, and then back to the EGR valve. And that's really how simple that is. So now let's go to the diagram on the board so I can explain how it works, and then I think most of you can already form an idea if it's wise to remove it or not. On the board we have exactly the same elements as what we have seen on the Defender. So we got an air filter, a turbo, the MAF, intercooler, the EGR valve, the engine. We've got the exhaust, we've got the tube, which is feeding back exhaust gases back to the EGR. We got the vacuum hoses. Remember that disc on top of the EGR valve with the vacuum hose. And then we have what we call the modulators. There are two modulators in this case, but I'll explain you that in a minute why that is. I have not shown you those because they're a bit on the side, but I will show them later. And then of course we have the ECU, which I haven't shown you, but that's sitting underneath the right-hand side seat. And we have the vacuum pump, which is mounted actually on your alternator. And that's all there is to it, really, not very complex. Now, I have to tell you that there is a difference between a Euro 2 and a Euro 3. And the difference is on the EGR and the cooler for the gases that are returned. If you have a Euro 3 Defender, then you have a hose feeding back the exhaust gases from the exhaust manifold through a exhaust cooler, gas cooler, and then back into the EGR valve. And this valve can actually close or shut. So it prevents gases coming in, or it allows gases in. And this valve can be modulated. It doesn't have to be open or closed. It can be anywhere in between. And how far that goes is actually done by vacuum applied to the top of that membrane. But the vacuum is applied in a certain quantity based on the signal coming from the ECU. And the signal from the ECU is what we call a duty cycle signal, which is then controlling the valve modulator, which will feed more or less vacuum to that membrane to open or close or partially close that valve. If you have a Euro 2, that's the only one you have. If you have a Euro 3, then you have an additional butterfly, and the butterfly here can actually block off the cold or the fresh air coming from the turbo. And that is also controlled by a vacuum tube coming from a second inlet modulator. Again, this one is controlled as well by the ECU. Now, the ECU in this system has a lot of sensors. It has, for instance, the engine temperature. It has the position of the throttle pedal. It knows how many RPMs we are running. It knows the air temperature. It knows the map. You know, it has all that information, so it knows exactly when you're going to need power and when you don't need power. I think I will take you now through a cold start, and then we're going to take you through a cruising condition. Then we're going to go uphill, and then we're going to go downhill. And then we see how the system should work. So let's do a cold start first. So if we are in a cold start situation, we don't want to recycle any gases into the intake manifold. And the ECU is programmed to do so. The ECU knows the temperature, you know, it knows all that, it knows it's a cold start, and it will actually send a signal to the valve modulator, which will then apply no vacuum at all to this valve here, to the EGR valve, and the valve will be fully shut, so no gas can come in. If it's a Euro 3, the same thing happens, but also the butterfly here will be wide open, so we can get all the fresh air in that we need to have to start the engine. While the engine is running on idle and while the engine is kind of warming up, nothing is going to happen. We're going to keep it like this. But once the engine is reached at a temperature of 40 degrees centigrade, that's the moment in time that the ECU may decide to start activating the EGR valve. So start to recycle some gases. And how much depends, of course, what our demand is at that moment in time. If you're driving and you demand power from it, you're at 40 degrees centigrade, it's not going to open up. But if you don't demand any power from the engine, let's say we're just cruising along and we have reached 40 degrees centigrade, then the ECU will say, oh, look, I'm cruising along. I know my RPMs, I know my speed, I know all the temperatures, I also know the position of the throttle, the pedal. Now the pedal now, if you're cruising along on a flat road, you basically release that pedal quite a bit. So it's not very depressed down. So you don't demand power. So the ECU senses that, and it has a map, and the map will then say, okay, now it's time to activate the recycling valve. And it's going to send a signal to the valve modulator, which will then apply a vacuum over this red connection here, and this valve will then open up to some extent. It all depends on the condition, how much power you still demand, because there's still going to be a bit. So that can vary. Now we will have gases coming back in. It's going to mix now with the air which is coming in from the turbo, and now we're reducing the oxygen content because we have more gases in there, and now the end result is lower burning temperatures and the output is less NOx gases. So now we are in environmental saving condition. Now imagine that we are above 40 degrees centigrade and the cruising is done. We need to get a steep hill, so we need to go uphill. So we want to retain the speed that we have. So what do? We depress our gas pedal. If you depress your gas pedal, you will see it. Oh, I need more power. It also detects that there is a pressure change in the intake manifold. So it's going to act, and it says, well, if I need more power, I need to get rid of these gases. And it's going to, again, send a signal to the valve modulator. Vacuum will be removed and the valve will be closed this time. Now we have fresh air coming back in, properly charged and loaded. Now we have, of course, a higher burning temperature. We're having more NOx gases, but we have the power we need to have. Right, so now we're at the top of the hill. And what happens if you're going downhill? Well, typically you don't even depress the pedal in most cases if it's steep enough. So if that is the case, then the ECU will detect it. It detects the load, all this, and it'll say, oh, you know what? Now I can open up this valve in full and I can burn these gases again, reduce the NOx, but also I'm going to shut down partially or maybe even in full the air coming from the turbo. So I'm really going to burn or run really on a lot of exhaust gases, and it's not going to shut in full, of course, because then I think the engine would probably die, but it's going to be pretty near to closing. So now we really recycle a lot of it, and we really have reduced the NOx gases now. And then again, once you're at the bottom of the hill, we're cruising again, and maybe we go uphill again, and the whole thing can repeat itself. So as you can see, this is a modulated system that only applies emission control when it's affordable, so not when you are demanding power. So a good working system like this will not cause any problems. So even if you do an EGR valve bypass, and the bypass is simple, all you do is removing all this with a one big tube. You remove all the vacuum stuff, none of that, and all you do is one big tube. That's it. So all this stuff doesn't play any role anymore. It's okay. The ECU won't know. I mean, there's no feedback mechanism to the ECU, so that's good. Don't forget to block these two vacuum hoses. So the EGR blanking is just making sure that you get no more exhaust gases in. And the principle there is simple. You install this part here onto the intake manifold, and as you can see, this is just an empty pipe. There's no connections on it. You actually block with a panel or a plate the exhaust gases coming in. In fact, you do it over here, and then you block the two vacuum hoses so you don't lose vacuum, and that's it. So now your engine is always running in the, let's say, the power mode, so higher burning temperature, more NOx, right? So it doesn't really matter now. This is good. This is always going to work, even on moments where you could have reduced the NOx gases, but now. So now the question is, why would you install the EGR blanking panel? We can now have a short discussion on why would you remove it and why not. If you're a tree-loving person, then you most likely don't want to remove your EGR valve at all, if it's working properly. It's not going to make any change for you. But then again, I don't think that tree-loving people would buy a Defender anyway. They probably would drive an electrical vehicle. But all right, besides that, so if the EGR system is working properly, you have no benefit at all to put a bypass in. It's not going to make any change. Well, maybe you gain 2, 3, 4 horsepower, and that's it. Nothing more than that. If you really want to have better performance with an EGR system in it, then just renew your intercooler, get a more performant intercooler, or even clean out your old one. That's going to make a difference. But don't mess around with the EGR valve. There's no need for that. In my case, I'm going to do an uplift on my ECU to a stage 1. I'm not exaggerating, but just a stage 1. And now I need to remove the EGR valve, and that's what I'm going to do. I'm also going to change my intercooler with a new one. Not a high performance one, but just a new one, so I have a nice stream through it. There's another reason why I am going to change it, and that is for the very simple reason that I like to have my engine breathing better. I'm not talking about the NOx gases, I'm talking about the intake manifold. See, if I have to work in a room with a lot of smoke, or I can work in a room with a lot of fresh air, I prefer the fresh air. It will make me breathe better. It will make me work better. And that's exactly the same on the engine. So you're going to keep the intake manifold a lot cleaner. Everything will be a lot cleaner if you remove that EGR valve, because after all, these exhaust fumes are pretty nasty fumes with all kind of debris in it. So, you know, I don't want to get this into my intake manifold. So that's my reason as well. So better breathing. I have less parts that can go wrong, and that's a big thing. And I'm going to do a stage 1 tuning on my Defender. That's why I'm going to do it. I don't know what your reason is, but if your reason is to increase horsepower, don't do it. It's not going to make a difference. Now, I've heard stories, and I read stories from people on the internet that were saying, oh, you know what, I removed my EGR valve, and now I have so much more horsepower. My car is so much more responsive. Oh, that's nonsense. He probably had a stuck EGR valve of some sort. You know, it probably was open all the time or something. He had a defect. And of course, if you then remove it, it looks better. All right, enough of that. So now, before we do anything else by removing it, let me show you a few things you can do for troubleshooting. If you're going to troubleshoot your ECU, there's different ways of doing it. And a nanocom, which is an OBD2 diagnostics tool for the Landrover Defender, is very handy for that. So if you're serious about owning a Defender and doing your own maintenance, you might want to get this. I might have another video on this part altogether, but you will see on this display here, once we have it hooked up, that you can actually see the duty cycle for the 2 modulators for the EGR valve. Of course, if you only have one modulator, then you will only see it for the one that you have. But on this one, you will see it both for the butterfly and the EGR valve itself, and it will be displayed on the display. And then that's the moment in time that vacuum will be applied. So that is very handy, and then you can measure that vacuum if you want to. It also will show you the temperature of the engine and the RPMs and all that. It's handy. I'm not saying you need to have this, but it's handy to have it. But there is another tool you're going to have. And the second tool you're going to need is what we call a vacuum pump. And with that one, you can check the membrane on your EGR valve, both for the butterfly and the EGR valve itself, if it's a Euro 3. So you just hook it up to the top of the membrane, then you press here, you create that vacuum, and let it sit there for a few seconds, and you'll see if the vacuum stays. If the vacuum doesn't stay, then the membrane is gone. So then the EGR valve is not working properly. Very easy test and very simple to do, but of course that's only testing the membrane. You might also need a vacuum meter to hook it up to the hose which is coming from the modulator to see if your modulator is actually applying vacuum to your EGR valves. And for that one, you just use an ordinary vacuum meter, which I have hanging here. Let me show you that. And here you have 4 vacuum meters, but you don't need 4, of course. You only need 1. But make sure the one that you have can go up to about -1 bar. Around 0.6, 0.7, that's where it should be once the vacuum is applied. And you can hook up this hose then to the vacuum hose which is coming from the modulator, and once the EGR is kicked in, then you see that vacuum being applied. And it's good to check this while the engine is warming up. So when the engine is cold, it's going to get to 40 degrees, you should have no vacuum. Once you hit 40 degrees and you give it a little bit of throttle, then you should see the vacuum being applied. So these are some basic tests we can do. So now let's start and with the first test. The first test we're going to do is to see if the membrane is still working on the EGR valve. And the top one is the one that controls the gas coming from the exhaust back into the intake manifold. There is another one on the side for Euro 3, which is then controlling the butterfly, which can block the air incoming from the turbo. But let's start with the top one. So I'm going to hook up my vacuum pump to this membrane, and then we create some vacuum and we'll see if we can hold it. So we remove the hose here, the vacuum, which is coming from the actual modulator, and we'll put our test hose up, and then we're just going to pump and see what happens, right? So I'm going to try to pump to about half a bar negative, and that's where we are. And let me pump a bit more because All right, so you can see we have about half a bar and it stays there, so that is good. So I know the membrane is working. In fact, if you pull it off, you can actually hear the valve. I don't know if you could hear it. What I don't know for sure if the valve is really closing or not. So that's one test. Now let's do the second one, which is the connector right here. And I'm just going to move the camera around a bit so you can better see it. So now this is 03, we do the second vacuum, which is controlling the butterfly, and you can see that part here, that you should see moving once we apply vacuum to it. So I'm going to disconnect it, and I'm going to hook up my test hose, and I'm not going to show you the vacuum pump, but it's all the same. So I'm just going to start pumping. Now what's that part? See that moving? See that? See here? That's actually now that butterfly. So here's the hose coming from a vacuum meter, and I'm just going to stick that in here. All right. And now I'm going to start up the car, and I'm going to wait till I hit about 40 degrees centigrade, and then I should see vacuum being applied here if I don't apply power to the car. This is going to be a little bit tricky to show. I'll try to show you both the vacuum meter and a little bit on the nanocom, because that's where I also can see what is happening. So let me connect the nanocom. So the only meter which is hooked up is this one right here. So keep an eye on that one, and we'll see what happens. So right now my temperature is at 16 degrees centigrade. So I'm going to start the engine and we'll see. So right now you don't see any vacuum, and there shouldn't be any. So now my engine is on temperature and we go into cruise mode. So I'm going to increase the RPMs and watch the vacuum meter. See how that creates vacuum? And I'm having now 80% modulator rate. I'm cruising along again, and now I'm going to let go, and I'm now running at idle, not doing anything because we're on idle, but if I start cruising a bit, then you should see that going up. So now we're cruising along, and now you can see the EGR valve, right? There we go. I've shown you on how you can check the membranes on your EGR valve. Of course, you don't know if the valve is really closed or not, or if it's clogged up or stuck. That you don't know, but at least you know the membrane is working. We did it both on the EGR valve and on the butterfly valve. It worked fine on this Defender, and we also checked that the vacuum was fine whenever the ECU commanded to apply the vacuum. We verified that actually with the nanocom. So that is always a good check, the meter and the nanocom together, and you could see that we have about, I think, half a bar, which is good enough for that membrane to open up. So now it's time to replace it, and that is pretty simple, and for that one you can get a blanking kit. The blanking kit comes in different versions, and I have the El Cheapo version. So all what you have is an aluminum tube, here that is, which one side connects to the intake manifold, and to do that you got a seal that comes with it, and then you bolt it down with those new bolts. And then the other part that comes with it is a blanking panel, which has to go on the exhaust system where the recycling tube is connected, and you blank that off. And it has two new bolts. Some of them had 3 of these plates before. I only got 1 on this one. I guess 1 is enough, but ideally you would have to have 3 if you have a Euro 3. EGR valve fitted. Some EGR valves actually have here on this side a connection for that tube which is coming from the exhaust, but that's a fake tube. That's a fake, and it's actually blocked. But it looks like it's going in there, and it has also a fake vacuum connection on it. But okay, you don't need this. I don't need that fake stuff, so I'm just going to install this. This is pretty easy stuff to install. And once it's all installed, we just going to go for a test ride and see how that goes. Removing the EGR valve is very simple. Disconnect the vacuum hoses, and in case you have to, like in my case, remove those. We put this aside. Don't forget to block those at the end. Undo the 4 bolts. and the hose here, which is coming from the intercooler, and then the metal hose on the bottom, the bolt there, which is feeding the exhaust fumes into the EGR valve, and then the whole thing will come off. So this is pretty straightforward stuff, not very complicated. So I'm going to start with disconnecting the hose coming from my intercooler. Okay, and you can already see the garbage that's inside. Look at this. You know, it's like oily. It might actually be oil coming from my turbo. Yet to be seen. So the next step is to undo the bolt on the side on that hose. I'm now removing the bolts that are holding the EGR valve to the intake manifold. That's also an 8 mil. So that came out, and here is the EGR valve. Now that the EGR valve is off, you can actually see the intake manifold, and you can see how dirty that is, right? So let me just do this real quick. Can you see? See that? That's the kind of crap you get inside with an EGR valve. So here we have the EGR valve, and you can see all the crap that we have in here. Oil in here can either come from the exhaust fumes, but it may also come from your turbo through your intercooler. So I think the intercooler will be pretty much clogged up here as well. You can see the top membrane and the rod going down with the valve. This is the valve that is going to allow gases to come in. And you can see already the kind of stuff that's on there. Not really good, is it? So really, this is really dirty. On the other side, you have that butterfly, which is controlled by the vacuum here on the side. That's then going to open or close and shut off the air coming from the turbo. So with that, let's see if this valve is really working. So I'm going to apply some vacuum on the top, and then we can test it. If you want to check that the EGR valve, which is the one on the bottom, is really working, then you should take off your EGR valve and then apply with your vacuum pump some vacuum to it and see what it does. Let's see, it's now opening up. And there we go. Now it's fully open, and it stays open. So that's good, because my EGR valve was properly working on this Defender, as you can see. It's slowly losing some vacuum. As you can see, it's going down, but it may be my hoses that are actually leaking, or my pump. There we go. So now we can close it. So let's do the same test now for this other valve, which is the butterfly that shuts off my airflow from my turbo. So let's turn that around and see what that does. All right, so again, I'm going to hook up my vacuum hose to the activator and press some and create some vacuum. And you can see that guy is actually really closing completely. So that would shut down that airflow coming in from your turbo. All right, good. So this EGR valve is actually working, but you can see how dirty it is and how much sludge there is inside. So I'm going to clean this baby up completely, but I'm not going to put it back. I'm going to keep it aside. I have placed a blanking panel on the cooler. I'm going to place another blanking panel on the other side, and then we'll place one on the exhaust manifold itself. So I'm going to use 3 blanking panels. In fact, you could only use one on the exhaust, but I like to use 3 so nothing can get into this cooler in case I ever want to use it again. So now we're going to install the EGR bypass, and I'm going to fit it first in the hose which is coming from my turbo. And we'll install the seal. All right, come on. Okay, let's see if we can loosely fit it. Tighten this up a little bit. you might want to put a little bit of thread lock on the bolts. I haven't done it because I might even remove this again. It all depends how it goes, but I don't expect any problems. So now we will tighten up the hose coming from the intercooler. All right. That's good enough. And to block off the vacuum hoses, I'm using small pieces of plastic, solid plastic. So let me stick this in here. All right, so you see, now this can't come out anymore, and it's in there and seals very well the vacuum. Same thing for this one. All right, so that's done and sealed up. So now I'm going to tie this all together nicely with some tie wraps so we can always use it afterwards if we need to. I have installed the EGR blanking kit. We also plugged up the vacuum hoses and we tie wrapped them down to the side. I didn't show you that, but I don't want to have them loose. I also installed the sound protection on the engine, so now we can actually start it up and probably do a test ride. So hear that sound? This is my fuel pump. This is something I have to fix as well on this Defender. A well-known problem. I don't know what you think, but this sounds like it's running a lot nicer. I'm not sure, but it really sounds like it. I decided to go for a test ride anyway, although it's after midnight, and I have to say that drove better than what I expected. Now I don't know if it's between my ears or it's really the case. So I couldn't resist to go for a test ride, and although it's after midnight, and I didn't take the camera with me because it's dark. But what I kind of sensed on the car is that it kind of is far more responsive. So when I was cruising along and I would accelerate, it would pick up very quickly. So the acceleration and the pickup is much better. It's not as hesitant as before. And I don't know if it's this between just my two ears and just because I changed it and I think it's better, but it certainly feels like that. So all by all, this is good. And I also noticed that the engine is running nicer, more even. The temperature didn't go up much more than what I saw before, around 80 degrees centigrade. So that is good. Anyhow, we'll see in the next videos after we have changed the intercooler if we get some more performance improvements, and then we'll do the update of the fuel map to stage 1, and then I should get a little bit more horsepower. But anyway, I hope you enjoyed this video, and I'll see you in my next one. Bye bye.